Good morning, children. In previous class, we have studied about Vesper theory. Let me recapitulate that Vesper theory once before going to valency bond theory. What that Vesper theory explains? It explains about only lone pair of electrons as well as bond pair of electrons in valency orbits. In valency orbit, it explains only about lone pair of electrons as well as bond pair of electrons. That is the first point what we have to keep in our mind. Next point is it explains about structure of molecule based upon one force. What is that force here? A repulsion force between lone pairs as well as bond pairs of electrons, which gives a symmetrical structure. It explains about second point is that one. Structure of molecule based upon one force, that is repulsion force between lone pairs as well as bond pairs of electron, which gives a symmetrical structure. That is second point. Third point is what? The changes in structures. The structure what else we are getting here, that structure will be get changed depending upon differences between lone pair as well as repulsion force between lone pairs as well as bond pairs of electron. The changes of structure of differences can be clearly explained. It will be attained based upon a force, repulsion force between lone pairs as well as bond pairs. If you go for the repulsion force, orbit will be existing here. Between lone pair and lone pair, more repulsion force will be there than that of lone pair and bond pair, than that of bond pair and bond pair. These three points we have to keep in our mind, which gives explanation by what? Vesper theory. And one more point is what? It could not explain about any orbitals. Overlapping of orbitals such as s orbital, p orbital, d orbital. It explains only about lone pair of electrons as well as bond pair of electrons, that which gives certain structures such as beryllium chloride whose angle is 180 degrees, boron trifluoride whose angle is 120 degrees, methane molecule whose angle is 109.28 minutes, ammonia molecule whose angle is 107.48 minutes, water molecule whose angle is 104.31 minutes. This is the total concept of Vesper theory. Next thing is what? Valency bond theory. This valency bond theory talks about orbitals. It speaks about orbitals. S orbital, p orbital, d orbital, f orbital it talks about. It was first proposed by Hettner as well as London in the year 1927. Later on, this theory is modified by Pauling as well as other chemists. What does this theory based upon? We can call valency bond theory as VBT theory also. This theory mainly based upon four factors. It talks about 4 points. First one is atomic orbitals. Second one is electronic configuration. Third one is overlapping of atomic orbitals. Fourth one is hybridization. When it comes to atomic orbitals as well as electronic configuration, what is called as atomic orbital? The region, the probability of finding an electron in an atom can be defined as nothing but what? Orbital. We are having 4 types of orbital: s orbital, p orbital, d orbital as well as f orbital. Next one is what? Electronic configuration. What does it mean? based upon energy of orbitals. Systematic arrangement of electrons in those orbitals is called as nothing but what? Electronic configuration. Here it talks about what these 2 points explain mainly about what basic concept of formation of chemical bond. How a chemical bond forms. Here, to form a chemical bond, orbital overlapping, orbitals must be halfly filled, it must be get existing. If it is half filled, then pairing would be taken place. That pairing can be result in the formation of chemical bond. Next point is what? Overlapping of atomic orbitals. How these orbitals are overlapping? These orbitals can be get overlapped in 2 ways. End-on-end overlap or head-to-head overlap or laterally overlap or side-by-side overlap. Overlaps will be of 3 types which we would study in intermediate second year. The overlaps are positive overlaps, negative overlapping and zero overlapping. When it comes to formation of bond, will be clearly explained by positive overlapping. Positive overlapping, what happens there? It explains about bond formation in which SS overlapping, SP overlapping as well as PP overlapping. The overlapping of orbitals, in what way they are overlapping, it explains about strength of the bond, how much strength the bond is. If the that overlapping will be 2 types, end-on-end overlapping and side-by-side overlapping. End-on-end overlapping or head-to-head overlapping is called as what? It will be happen on internuclear axis, so that the bond will be much more strong. The bond formed between 2 orbitals when they are overlapping with end-on-end overlapping. That bond is much more strong, which explains about strength of the bond. Similarly, side by side, 2 orbitals are existing in this way throughout the internuclear, exactly perpendicularly a bond, perpendicular to internuclear axis. What is the bond forms? That bond is called as pi bond. That type of overlapping is called as side by side overlapping or lateral overlapping. Due to that reason, one bond will be get formed. That bond is called as pi bond. Already we have studied what pi bond is the weakest bond as well as sigma bond is the strongest bond. Therefore, depending upon overlapping of orbital, strength of the bond can be explained. If strength of the bond is explained clearly, it gives more directional property there itself. It deals with what property? Directional property. If it is having directional property, structure of molecule or shape of molecule can be get explained. This directional property can be explained within p orbitals as well as d orbitals, f orbitals, but whereas it cannot be dealt with s orbitals, as s orbitals are in spherical in shape, so the overlapping cannot be taken place in one specified direction. Shape of the molecules, directional property results in the formation of what? Shape of the molecules are structures of the molecules. Some examples let me see. Already we have seen in Vesper theory. Some example, beryllium chloride. The angle is equal to 180 degrees. How it attains the structure can be explained there itself. Boron trifluoride, 120 degrees having trigonal planar shape. CH4 molecule is having linear shape, BCl2 is having linear shape and angle is equal to 180 degrees. Boron trifluoride is having trigonal planar shape, having angle is equal to 120 degrees. Methane molecule whose structure is tetrahedral, having angle is equal to 109.28 minutes. Ammonia molecule whose angle is 107.48 minutes, shape is trigonal pyramidal shape. H2O molecule whose angle is 104 degrees, 31 minutes, and shape of the molecule is angular or V-shape. This particular structure of the molecule can be much more perfectly explained by a concept called as hybridization. By this, just general introduction of valency bond theory we have completed. In next concept, We'll study in detail study of valency bond theory. Why this particular theory came into exist? Let me discuss. This theory is also called as quantum mechanical model or a theory, also we can call it a quantum mechanical theory, also we can call it a. Why this particular theory? This theory was suggested by whom? Linus Pauling in the year 1954. In the year 1954, this theory was suggested by Linus Pauling to overcome the drawbacks of valency shell electron pair repulsion theory. What are the drawbacks here? It failed to explain strength of the bond, whether the bond is strong or weak. It could not give a clear explanation. But this theory, to some extent, it will give a clear explanation regarding strength of the bond. Second point is what? It failed to explain extra about electronic nature of covalent bond. How the electrons within the particular covalent bond they will be get existing. That particular concept also, to some extent, we can clearly explain by using one theory. That theory is called as valency bond theory. It has some important points. It has 4 important points within that. Let me first of all go with what? First point. We have already studied that clearly that to form a covalent bond, valency shell orbitals in which unpaired electrons will be there. Those unpaired electrons which are existing in valency shell overlap each other. Overlap each other and a bond will be get formed. That bond is called as covalent bond. Within this, he has given a little bit modification. What does he has given is, for example, he has taken formation of hydrogen molecule concept. Within that, he has taken hydrogen. Hydrogen atomic number is what? 1. Electronic configuration is 1s1. So it has one unpaired electron. That one unpaired electron he has taken it with upward arrow, which is called as a clockwise spin. Next one is what? Another hydrogen atom he has taken there itself, in which whose atomic number is 1, electronic configuration is 1s1. It is also having one unpaired electron. That unpaired electron is represented with what? Anti-clockwise direction or opposite spin. This hydrogen atom is having 1 electron. This hydrogen atom is having 1 electron. These two hydrogens overlap. The valency orbitals of these two hydrogens overlap each other. Overlap each other and form a paired electron of opposite spin. These two electrons will be shared by this hydrogen atom. These two electrons will be shared by another atom, so that hydrogen molecule will be get formed. To form a molecule, a covalent bond, 2 electrons. One electron must be in clockwise spin, another electron must be in anti-clockwise spin. For example, if I am taking this is anti-clockwise spin. And another electron I am taking it up upward arrow, which is having clockwise spin. Together form a paired electron of a bond. That bond is called as covalent bond, and that molecule, for example, we are taking as what? Hydrogen molecule. This is regarding first important point. Coming to second point. Within second point, when the bond is forming there, that bond may be depending upon the overlapping of valency orbitals. If the overlapping of valency orbital is greater, then one bond will be get formed. That bond is what? Stronger bond will be get formed. As overlap is much more stronger it indicates what happened depending upon the overlapping. If overlapping is more greater, then strongest bond will form. That strongest bond is called as sigma bond. Symbol of sigma bond is this. Similarly, weaker the overlapping is the vice versa. Weaker the overlapping means what? Weaker bond will be get formed. That weaker bond is called as pi bond. Symbol of pi already we have studied in mathematics. Pi symbol it will be there. That is second point. By these 2 points, we can clearly say that in which direction the bond is forming. Therefore, directionality can be explained here. Except s orbital overlapping, directionality can be clearly explained in other orbitals. That is second point. Coming to third point, each bonded atom has its own orbitals. Example I have taken here. Formation of chlorine molecule I have taken, whose atomic number is 17. Electronic configuration is what? 2, 8, 7. It is having 1 electron, 1 unpaired electron in valency orbital. 1 unpaired electron in valency orbital. So that what happened, that 1 unpaired electron is existing here. But it has its own orbitals here. See here, it is having its own orbital. First orbit, second orbit. First orbit 2 electrons, second orbit 8 electrons. It has its own electrons, but only the valency orbital electron will be sharing that electrons. So that a bond will be get formed. That bond is called as covalent. That bond is called as covalent bond. Only valency orbital electrons in which unpaired electron is there, or that unpaired electron will share with another unpaired electron. It has its own orbitals as well as electrons filling it up. It is also having its own orbitals and filling up with valency, filling up with electrons. But the valency orbital, where it is having unpaired electron, it overlap with each other and form a paired molecule, a paired bond. It will be get formed. In that way, chlorine molecule will be get formed. That is third point. Coming to fourth point. Fourth point clearly explains about multiple bonds. If a molecule has more than one bond, we call them as what? Multiple bonds. Within these multiple bonds, first bond, we are taking first point here itself. First point will be what? It explains about overlapping of orbitals by means of end-on end overlapping or head-to-head overlapping. Where they will be overlapping? On internuclear axis. Example, see here. I have drawn one molecule. Formation of a molecule, I have taken any molecule. P orbital is having one lone pair electron. Another p orbital is overlapping on one axis. This axis is called as what? Internuclear axis. Here these two molecules, these two orbitals are overlapping end on end. Head to head overlapping is taking place. Due to that reason, one bond will form. That bond is called as sigma bond. The strongest bond can be get formed. Next point is what? Second bond. More than one bond. One bond is called as multiple bonds. Second bond. How it will be get overlapped? Side by side overlapping or laterally they overlap. In this way, two orbitals will be there. Here is having one electron, here is having one electron. How they will be overlapping? Side by side. To do that one, I have taken a molecule. Means what? Exactly perpendicular to internuclear axis, orbitals will be get existing. Here p orbital is there exactly perpendicular to internuclear axis. So that here this electron and this electron will be sharing in a side by side overlapping. Due to that reason, a bond will be get formed. That bond is called as pi bond. By using these four postulates or important points, valency bond theory can be explained clearly. This is suggested by Linus Pauling in the year 1954. This is totally about valency bond theory. Okay, children, now coming to valency bond theory, some examples. 3 examples will discuss that itself. First one is formation of chlorine molecule in which single bond will be there. Formation of oxygen molecule in which double bond will be there. Formation of nitrogen molecule in which a triple bond will be there. So individually, one after the other, we'll discuss about these three bonds. First of all, formation of chlorine molecule, which gives example for what? A single bond. If you go for chlorine, atomic number is 17. Electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. If you go for p orbital will be having three subshells called as px, py, pz, as it belongs to third p shell. Therefore, 3px, 3py, 3pz. Similarly, coming to one more chlorine atom. Similarly, electronic configuration is 1s2, 2s2, 2p6, 3s2, 3p5. 3p5 orbital, 3px, 3py, 3pz, in which one unpaired electron is existing. Here one unpaired electron is there, here one unpaired electron is there. P orbital, 3pz orbital, 3pz orbital of one chlorine atom I have taken, 3pz orbital of second chlorine atom I have taken, overlap. Which overlapping it is called as end-on end overlapping, head-to-head overlapping. Due to that overlapping, what happened? A bond will be get formed. That bond is called as sigma bond. A strong bond will be formed. Why means it is acting upon internuclear axis. If the greater the overlapping, stronger the bond will be there, as it is overlapping on internucleus axis, head to head or end on end, bond will be much more stronger. Here one single covalent bond is formed, such that what happened? Chlorine molecule formed. Coming to second point, it is what? Formation of oxygen molecule. What is the atomic number of oxygen here? 8. Electronic configuration is 1s2, 2s2, 2p4. I am taking p orbital, 2p orbital I am taking 1, 2, 3, 4 electrons. Therefore, 2py and 2pz, two orbitals are unpaired. Coming to one more oxygen atom, whose electronic configuration is 1s2, 2s2, 2p4. Diagrammatically, if I am representing here, I represent in this way as that 2px and 2py are unpaired electrons. Therefore, 2px, 2py, 2px, 2py overlap each other to form two bonds, two covalent bonds. How it will be get formed? Let me come to the diagram. Here two unpaired orbitals are there. I have taken only two unpaired orbitals. One is 2px orbital, other one is 2py orbital. 2px orbital I have taken one electron, 2py orbital I have taken one electron. Another oxygen molecule atom I have taken in which 2px and 2py orbitals are there. Opposite spin electrons I have taken. So that what happened? Two orbitals, these two orbitals, 2px, 2py, 2px overlap end on internuclear axis. Therefore, strongest bond will be get formed. That bond is called as sigma bond. Coming to 2py and 2py orbital, they are overlapping side by side. Or laterally they are overlapping. Due to that reason, what happened? Weaker strength will be there itself between those two orbitals. Due to that reason, one bond will form. That bond is called as pi bond. Here, one sigma bond and one pi bond form within oxygen molecule. Coming to next concept is what? Formation of nitrogen molecule. Atomic number is 7. Electronic configuration is 1s2, 2s2, 2p3. If I represent p orbital is having three subshells, 2px, 2py, 2pz. In each orbital, one unpaired electron. Three orbitals are unpaired. Coming to one more nitrogen atom, having atomic number is equal to 7, 1s2, 2s2, 2p3. 2p orbital is having three unpaired orbitals. Therefore, three unpaired 2px, 2py, 2pz is having three unpaired orbitals. Here, three unpaired orbitals are there. I have taken three orbitals, three p orbitals. One is 2px orbital, other one is 2py orbital, other one is 2pz orbital. Individually, one electron, one electron, one electron. Similarly, I have taken one more nitrogen molecule, 2px, 2px, 2py, as well as 2pz, in which individually one unpaired electrons are existing. Now these two orbitals overlapping. 2px orbital are overlapping end on end Strongly they are overlapping on internuclear axis. Due to that reason, sigma bond will be get forming. When it comes to 2p orbital of one nitrogen atom, 2p orbital of one nitrogen atom is having unpaired electron. Side by side they will be overlapping. Therefore, weaker the strength will be there, weaker overlapping will be there. One pi bond will be get forming. Similarly, 2pz as well as 2pz are also having unpaired electron, that two side by side overlapping. Here also weaker overlapping will be taken place, exactly perpendicular to the internuclear axis it will be taken place. Due to that reason, one more pi bond will be get forming. In this way, nitrogen molecule will form three bonds. One is 2px, sigma bond end on end overlap. 2py, 2py, side by side overlap. Pi bond will form 2pz as well as 2pz, side by side overlapping pi bond. One sigma bond and two pi bonds will be forming within nitrogen molecule. Coming to oxygen molecule, here two are there, one sigma bond and one pi bond will be get forming. 2px, end on end overlapping. Sigma bond will form 2py, side by side overlapping, pi bond will be get forming. Among this, one pi bond and one sigma bond here. When it comes to chlorine molecule, only one bond will form, that two upon end on end overlapping with all internuclear axis, and a bond will be get formed. That bond is called as sigma bond. We can call it. By this, we have completed valency bond theory. Tomorrow we will discuss more one example of valency bond theory. Okay, children, within this topic, what would be the worksheet of us? Directly you may ask, what is meant by valency bond theory? Who suggested valency bond theory? What is another name of valency bond theory? Also he can ask it. Individually, what are the important points of valency bond theory? He can ask 4 points are there. 4 points indicates 4 marks. Each point gives 1 mark for us, so that 4 points we have to study for 4 marks question. And he may ask it clearly, explain how the covalent chlorine molecule will be formed based upon valency bond theory. We know we have studied clearly about what covalent bond formation on Lewis dot structure also. Directly may ask, based upon valency bond theory, how chlorine molecule will form. And based upon valency bond theory, how oxygen molecule will form. Already we have studied oxygen molecule formation based upon Lewis dot structure. But by using valency bond theory, how this particular oxygen molecule will form. He may ask that one also. And formation of nitrogen molecule based upon valency bond theory also he can ask. These 3 questions can be given oxygen molecule as well as nitrogen molecule for 4 marks. When it comes to chlorine molecule, it is for 2 marks. And individually, what is sigma bond? What is pi bond? Differentiate sigma bond and pi bond. How it will be get formed? That also they can ask. If you concentrate on these all points, easily you can secure without losing a single mark within the concept called as valency bond theory. Thank you, children.